So welcome to B08 Data Visualization, our course, where this is demonstration video 3, looking at gghighlight and gganimate. So let's go to RStudio for that now. So to use gghighlight, first of all, we need to install that package and activate it. And what we can do then is use ggplot in the same way as before to plot the names from new one or tidy data. And we're going to group them by name and color them by name as well. And we're going to draw a line connecting them all together. So let's see the plotting background here. You see we just have a kind of a blank plot for all the different names. And then we're drawing lines, a faint line without a legend for all these names on the background of this. So this will show all the names together. So it's quite a lot of data, which you can see there. So it's not the most informative plot. But we can see there we have a gaps also between two different years for one that we removed earlier. So let's add text to denote the names. So here we're taking the labels from new $1 name that contains all our names. We're setting the color to be equal to the name. We're nudging it to keep it close to the name where possible. We're checking that the overlap is true and showing the legend is false. So let's look at that in more detail. So you can sort of see the trend of the names over time, where John was initially higher frequency, and then other ones became lower frequency. So let's try this again where it's more easily viewable. So with this data where there's quite a lot of things going on, what we can do is look at the high frequency names instead and focus on those, because they'll give us more information about our area of interest. So you can see there, my computer was struggling with plotting all that. We can see there the patterns for John and David and Jack and so on. So what we can do next is filter those names. So we're going up here to our part where we're going to filter those names. We're using the dplyr to pipe. If we're filtering the values for greater than 10, that's just arbitrary. And we're going to send that to ggplot. So you see there's no new one at the start here because we have our data frame is piped in by this pipe here already. And we're going to look at gghighlight to highlight the values that are more common here. So we can't show the colors for all of them. It's not going to make sense. We're just going to show the colors for some, and we're going to use a minimal theme just to avoid chart junk to keep things simple because there's a lot of data. So I've lost new one for some reason. Well, we had that already. And we're going to plot that out. And we're just going to focus on the more common names. So you can see there we've got the names, more common names highlighted: John in green, James in yellow, Michael in blue, and Patrick in purple. If we increase this criteria to say 1,000, a mean value of 1,000, you can see that those 6 are shown as well. There may be limitations in the number of values that can be shown here. So if we increase it to 100, it may just show those common 6. So we have other ones that are highlighted instead. So that's why we have to be careful over what we want to choose there. And we can consider, maybe we want to look at the low frequency names instead and see if any have a value below 20, an average value below 20. So certain ones that are more rarer can also be highlighted in the same way, but anyway, our criteria is there. So you can look at the really low frequencies ones whose maximum value is above 20 to see if there's any that fit our criteria, say as a few like Zachary and so on. So we can toggle different things in this criteria here, depending on what we want to show. So you can do the same with the girl name data and look at the frequencies of named frequencies that are of interest. Related to this is gganimate. Again, we're trying to highlight features that are of interest. So gganimate can take the temporal dimension here. We have time-based data. What you have to do is install quite a few packages, including devstool and installr, and that allows us to use this package called ImageMagick, which helps us create these videos or animations, which are simply a set of images collated together We use cowplot as well, and animation. We also use the dataset gapminder for just display here. And we're using the dev tools to install ggganimate. I used transformer and gifski as well. And we activate these libraries too. What we're going to use here is the Irish girls' names. So we're going to gather them as well in the same way as before, just giving the column names there for each of the years of interest. So you see there's fewer years that were provided there. And what we're going to do is remove those X from the years so that we can use that as numerical data, XG3. So let's view XG3. So we can see there we have the names, the years, and the values. So many of the values are very common, very uncommon. And you see there Mary is in the 1960s was the most common name, with some other ones that became more common gradually over time. So what we can do is look at those most common names and put that into a vector XG4, because again, if we have put every single name, all 3,000 plus, visually it'll be hard to interpret. So we're going to use the same structure we had before. We're looking XG4 by the year versus the log of the value, the names, grouping by name and coloring by name. We're adding a GM point for each of the names. So if we do that only, we'll see small dots for each of the years. So you can sort of see there, it's log scaled again. So we can add on the GM text again to add on the names to make it more clear. So you can see there, Mary and Sarah and Catherine and so on are more clear. What we can do to animate this is add on a command called transition states. So it's just transition states will organize this across the different years. So if we run that, instead of having our static plot, it will render it into a dynamic plot across the different years, which is the variable that we gave to the transition dates there. So you can see that's moving through. They look at the most common names for each of the years that are highlighted in text. So that kind of works. And it's not, if we widen our window here, we might see more of the different years. So what we can do is improve this. So we can leave a wake and a mark in our place that replaces that leaves the old values in place, which is something that is effective for us because we want to see where they're coming from. So that kind of shows their trend. So that's something we can do. So we're going to look at that plot now and see what difference those tweaks make. So you can see there, it's more apparent what is going on across the different years and the different patterns of different names. We can add other things like we're going to write this into a vector called gn, or adding a fade and exit to the animation. And we're also going to use the linear aesthetics during the transitions. So we can check this plot and see how that looks. So it's rendering it and it'll produce it now. We can see there, we can save the plot and write it out as a variable, and therefore we can manipulate it further if we wish to do that as well. So we're going to look at this plot GN, and you can see there we have the same sort of pattern there for all the different names. We can also focus on particular years. So we can view follow if we want to look at particular years. So this zooms in essentially to the years that are most of interest. It may not be effective here because it zooms right into the first few years that are just 2 or 3 years, and then kind of zooms out slowly. But it's maybe not as clear for the viewer to view them across all the different years. So you can see there, it's the same sort of information, but it's not quite as clear as we might wish to have compared to the other years, the other approach. So that's why this is perhaps less effective. And what you can do then is try this data using the Boyer-Norm data and plot these using animations. Remember that you can save these by simply right-clicking and save the image as onto your computer. and that will save them there. You don't need to think about anything complex for saving. GG save may also work as well. So that's the end of this video. Please see the next video on demonstration on heat maps.